Hello, welcome back. So we've got an intermezzo project here again. I've got this Grundig voltmeter. It's a Grundig UV4. Picked it up from eBay a couple of weeks ago. I posted a video also about it on the channel when I unboxed it from the package in which it arrived. And we're gonna have a look at it. Now, I also posted a picture of this voltmeter on a Facebook group for vintage test equipment, and it got 250 likes. So people really seem to like this thing, and that's why I thought, okay, let's make a dedicated video about it. We're gonna have a look at it, see if it still works. Well, it still works, I can show you. But then we're gonna have a closer look inside and see if something needs to be done. And then we're also gonna calibrate the meter, because yeah, I have to say that I really like the looks of it. It's a really big, nice voltmeter, and I couldn't really find lots of videos about this particular model on YouTube. Also no videos on calibration and these kind of things. So I said, wait, okay, I'm gonna film what I'm doing here, and I'm gonna make a video about it. Now the condition is okay-ish. It's definitely used. It's what you expect from a meter from this era. I don't know exactly what the age is. I think it's end of the 60s. It's used, and here you see this sticker is cracking a bit. It's coming off, but the sticker is on the inside, or the label, whatever it is, it's on the inside of the glass, so you cannot damage it by rubbing your fingers across it or something. So that's safe. I won't be able to do much about that. So we're gonna open it up and then clean it up as well. But maybe I can show you that it actually works. It's a bit out, so it's not really well calibrated, but it does work. Let me get some leads here. Yeah, it's plugged in. Okay. I will connect these to my my power supply. Just gonna measure voltage here, and we're gonna set it to volts. So this is DC, let's say 3 volts, and I'm gonna put my power supply to let's say 2 volts. Wow, it's actually spot on. Am I? Well, nearly spot on. Okay, I forgot to zero. Is it zeroed? Yes, it's more or less zeroed. Yes, it's on 0. That's good. Okay. 2 volts. Yeah, see, it's so the nice feature about from this meter is that it has a scale indicator. So it's indicating which scale you should read. Because I've changed to the 10 volt range. See, then it says you should read that scale, and it's just shy of 2 volts. See, it's showing 1.9, so it's a bit off. Here as well, here it's showing actually a bit closer to 2 volts. Let's go to the 10 volt scale, and let's increase the voltage a bit here. 3, 4, 5 volts. Yeah, it's also a bit off. Let's go to 9 volts. See, we are showing here 8.8 more or less. Let's go to the 30 volt range. Now having 16 volts. Let's go to 20. Yeah, also a bit low. See, it all seems to be slightly on the low side. The highest that my power supply can go without, yeah, putting the two together is 31 volts, and we are here at 29. So you see it's working. Let's go to the smallest range. This is, let's put it to 1 volt. That's not okay. Let's put it to 2.2 volt, and then go to this range. Again, it's showing 0.19 volts. So all the measurements are slightly low. But you see it's working. Same for negative voltage. So if let's unplug these. If I go to negative voltage, and then if I swap these around, Yeah, see, it's also a bit low. So everything is a bit low. Let me put it again to maybe like 3 volts, and then we can, if I enable the power, we go to the next feature, that's the center zero. Yeah, again, I need to center it first. Well, it's centered more or less, okay. Maybe a bit, yeah, like this. And yeah, that one is okay. See, it's 3 volt out in this direction. Let's swap the leads, and we are, yeah, about 3 volt out in that direction. That's looking good. Yeah, apologies for my voice. I'm still struggling a bit with a cold, but okay. The next button here is for AC voltage. Now, this meter cannot measure AC voltage out of the box. There is no circuit inside to measure AC voltage, so there is no rectification or anything done inside. So without an accessory probe, you can't measure AC voltage. So the idea is here indeed, you see the marking Tastkopfprobe for AC. So you need to have the probe here, and that was sold as an accessory, so not by default supplied with the meter, to measure AC voltage. Now, why they did this is because this probe could also measure high frequencies, and then if you are measuring really high frequencies, like into the tens or 100s of megahertz, then you need to have the rectification done as close as possible to the point where you're measuring, so inside the probe itself, because otherwise you get all kinds of weird reflections in the cable. So that's why they built this probe for really high AC frequencies, and then they said, well, yeah, if we are having a probe that can do the rectification anyway, why build in a circuit if it's already in the probe? So yeah. It's a bit of a cheeky move maybe to sell more probes or sell more accessories. I don't have the probe, so we'll have to build something in a future video. But for now, we cannot measure AC with this thing. Now this is current, and then this is resistance. The resistance measurement doesn't work. Let me show you. Let me connect some other leads here. So for resistance, we take this connector and this one. We put it into the resistor. We set the meter to 0. Well, infinity, because we're now reading the lower scale and that's swapped around. And then normally you should, to zero it, you should connect the leads together. And yeah, that's working, but see, I cannot get there, see. Normally you should connect both leads together and then you can calibrate it to 0, but it's all the way to the right and I cannot reach 0. Okay, I've got 10K here now. Yeah, no, it's not okay. And you see it's not stable at all. So yeah, so that's not good. Now why is it? I'd have to look at the schematic and it really seems quite normal that it's not working, because let me quickly show you. See, this is the entire schematic of the meter. If you have a look at this section over here, here we have the button for the resistance setting, and you see if you press this button, then you activate that switch, and what you do is you put a battery in circuit, and it's basically simply connected to ground. See? So what you do is when you put a resistor in there, you're basically putting 1.5 volts across the resistor, and then it measures the voltage drop. The meter measures the voltage drop. So this battery here is probably, yeah, long gone. It's still in there because it's still applying a voltage, but it's probably weak, so that's why it's measuring not enough of a voltage drop. Yeah, so that's probably normal, I guess, that the resistance measurement is not working. Yeah, and these are all the ranges. There are two versions of this meter available. This is the oldest one, which has a minimum of 0.3 volts, so 300 millivolt. And then there is a slightly newer version, and that one has an additional range of 13 millivolt. So that one is a bit more sensitive, let's say. Okay, let's turn it off. And let's open it up and see what we have inside. Okay, so first interesting thing is if we take off this cover plate here, you see that we have the power supply in here, and yeah, this foam is badly degraded. But this is the power supply, the AC power supply. And as you can see, you can remove it and you can also swap it for a battery. So if you're buying this meter and you want to run it off AC, make sure that this is included, because otherwise you will have to find the battery to fit in here. Now, I don't know how it comes out. Oh, simply like that. Okay. See, and here we have the connector for the, which connects it up into the meter. And yeah, the battery pack, how it works, I have no clue, but I'm glad that I got the AC adapter. And here we have also the voltage selector. So we can maybe start with that, or we can put it aside for a bit and open up the meter itself, because that might be more exciting to do. I guess we just need to simply remove these two screws here. Ah, yeah, and see, these are coming loose. We only need to loosen them, not remove them. Because now I should be able to, yeah, a bit more. No, you need to loosen them. What are those screws? This is weird. Come on. Ah, there it is. Okay. It is quite empty inside, and there we have the battery for the resistance measurement, and it's indeed been leaking. So we will have to swap that, obviously. And yeah, inside we have a big gaping hole, and then here we have the PCBs. Let me have a look at this, how I can get these loose. Oh, they are, you can simply slide them out. And you can slide the entire chassis out, like this. Okay, let me take everything out and I'll get back to you. Okay, so as you see, I have organized the workbench here a bit. I installed a new shelf here so that I could bring down my oscilloscope a bit lower, that it's much easier to work on. I installed the old signal generator here on the bottom, and I reorganized basically everything. And the idea is, when this multimeter is finished, or this voltmeter is finished, that I can put it over here on the shelf as well. But since this is a video about test equipment anyway, let me just give you a quick tour of the bench. Yeah, so I'm talking through the microphone of my cell phone now, so apologies for the sound. But I simply reorganized everything on the bench here, and yeah, it's much better now. Everything is much better organized. So we have on the bottom here the oscilloscope and the dim bulb limiter in the back there in the corner. Then here is the leader LSG10 signal generator. I also restored that one on the channel a long time ago. I don't use it that often, but it perfectly fitted underneath the shelf, so I put it there just to save some space. It's not that I use it every day, but okay, it fitted perfectly there. Then here we have my power supply. This is a pattern generator, which I never use, and it's also not working perfectly as it should, so it needs a service. But I don't know if I will spend the time servicing it because I don't work on television, so I never use this piece of equipment. But yeah, I had now space on my bench, so I decided to put it here anyway. Otherwise, it was sitting somewhere else, laying in the way. So this might go at some point. Here we have the wow and flutter meter that I restored recently on the channel. This is a new one which I picked up only this week. And that's a THD meter, so a distortion meter or analyzer. I still need to read the manual. It's quite a complicated piece of equipment, and I really need to still learn how to use it. I also don't know if it's in working condition, so it might need some service as well. Don't know yet. It's just sitting here because this is the place where I want it, but yeah, there might also be a video about this one at some point. Here is my regular signal generator, and this is the signal tracer that I also restored here on the channel, and that's also in perfect working condition. And then I have a CRT TV here as well. Maybe some of you have already noticed this TV on my videos and wondered what it is for. Well, this is for when I'm repairing like game consoles or arcade PCBs, anything that needs video output, then I have a CRT to test them with. So that's what I use that one for. It takes up quite a bit of bench space, but I think it's worth it. I spent quite a bit of time. It's a long time ago since I bought this one, but I was looking for the smallest CRT TV that I could find, which also had a SCART input. So those were my requirements. And this one, I found it rather close by on a second-hand shop. So it's a Sony Trinitron, very good tube and a very small CRT. Really nice, very nice TV. And then on top we have my bench amplifier and tuner, which I use most of the time just for listening to the radio while I'm working. But I also use it when I'm repairing a tuner, for example. Then I use the bench amplifier here. Or when I'm repairing an amplifier, then I use the tuner to connect it to the amplifier and get some music through it. And then the speakers here, those are the speakers that I'm using for this. They are connected to this amplifier. That hi-fi tower is not in use. Yeah, so I'm quite happy with how my bench looks right now. The most important things that are still on the to-do list are highest importance, better lighting, because I only have that stupid LED bulb, and it shows also in my videos that the lighting is not always perfect, so I need some decent lighting. I'm probably gonna put an LED strip here on the bottom of the shelf. Second on the to-do list is a new power strip, because my power strip there at the back, it's completely full, and when I need to use some of the gear that I use not that often, I need to switch power cords or I need to unplug something else and plug it in. So that's not convenient, so I need to have a second power brick. And then third, I haven't showed it yet, but I also mounted some speakers, some test speakers there, one on the left and there in the corner in the back. I don't know if you can see it. One for the right channel. And they need to be hooked up, and I need to mount some kind of switching or some kind of bracket so that I can easily plug in the radio that I'm testing or an amplifier that I'm testing to these speakers, these test speakers. So those are the three most important things, I think. And then this guy, obviously. So let's continue with this one now. Okay, maybe it's a good idea to start with the power supply. I already cleaned it up. It cleaned up quite nicely. And this is I according to me, it's a stabilized power supply. There's a transformer inside, which drops the voltage down to 12 volts. And there is also a transistor inside and some filtering capacitors. And remember that I said that this was an optional component, so it's strictly not really part of the voltmeter. It also has its own schematic, which I obviously forgot to print, but I don't think we will be needing it. Now let's see how we can open it up. I think I see one screw, but yeah, let's loosen that one. Okay, I think it's loose, yeah. Does this simply come off with one single screw? Yes, it does. That's spectacular. Ah, yeah, it's also clipped here a bit. Yeah. Just need to be careful that I don't break the plastic. Yeah, I think it's loose. Maybe not quite. Yeah. Oh wow, that's nice and full. There are two fuses, which both seem good because, yeah, the thing was working, right? There is a PCB here, which I don't really see how I can access it. Ah, maybe this slides down. Oh yes, indeed. Oh, nice. That's actually quite well made. This is the voltage selector. So you can choose between 110 to 20, and then this is 9 and 6, 7.5. Okay, strange. And here we have two capacitors. One is I can't see it. It's switched around. Here we have a AD156 transistor, and this is a bridge rectifier. Okay. Maybe I should fetch the schematic, because I can't really see here. Since it's plugged in, maybe I should also discharge these capacitors. Let me discharge the capacitors and let me fetch the schematic. Okay, I loosened this top one. That's a 250 microfarad capacitor, and it's connected. It was connected there to that pin of this transistor. And if you test it, then you see that the ESR is still okay, but yeah, capacitance is high, so it's 300 instead of 250. Still acceptable, but I'm gonna swap it out anyway. Now the big one, that's at 1600 microfarad capacitor. That's an interesting value. It's an annoying value as well. 250 as well. I mean, I will need to swap it by a 220, I think. This one, 1600 microfarad. It's connected all the way on the back, so one leg is connected to this part of the PCB. This solder, the other one, I don't know, because it's connected via a cable, and I also cannot get it out without removing this transistor. See, because the legs are in the way. So this is annoying. It's yeah, it's really compact, and I cannot take off these sides without desoldering them. See, because these are also soldered to the PCB and connected to the transformer, and the transformer is soldered to the PCB, and everything is connected to each other. And yeah, let me see what I can do here. Okay, both electrolytics are out. I had to loosen the transformer a bit so that I could shift it aside to pull this one out. See, this was the 1600 microfarad, and that one, same thing. ESR is fine, but the capacitance is really not okay anymore. See, 2000, and you can see it starts to bubble here, or to bulge. So I'm just gonna check my capacitors and see what I can Frankenstein together to get a bit close to this value of 1600. This one here, 250. Then I will mount these in, and I will show you the result. But really, they need to be changed to have a good and reliable power supply. Okay, both capacitors have been replaced. The 1600 microfarad one, I replaced it with a 2200. Yeah, that's significantly higher, but it's the only thing I had. Well, the closest I had, which also matched the voltage requirement of 30 volts. So I have a 2200, what is it, 35 volts in there now? Yeah, one like this, 2235 volts. That should be fine, even though it's a bit higher. The 250, 18 volts was replaced with a 220, I think 35 volts. Yeah, 35 volts. And they are hopefully hooked up correctly. So let me close this thing up and put it back in the voltmeter, and then we can see if nothing blows up. Before I close it up, I'm also cleaning here with contact cleaner the pins of the voltage selector, because they seem really tarnished. They are completely black. So I don't think it's a bad idea to clean these well. And then obviously rinse them afterwards to get rid of the contact cleaner, because this is not clean contact cleaner, so I do need to rinse them afterwards. But yeah, seeing how black they are, it's a good idea to clean these. Now it is mains voltage, so probably why it still works is because of the mains voltage. It will be enough voltage to bridge the tarnished contacts, but yeah, I don't like the look of these black pins here. So let me finish this up, put everything back together, and then we can test it in the voltmeter itself. Okay, so the power supply is back in, and I plugged the lead into the dim bulb limiter just to be sure. And let's see. Yeah, that looks fine. I don't have any leads connected or anything, so the switches seem to work. Let's do a quick test. I have 3 volts now on the power supply. Yeah, that's good. It still works. Alright, okay. Now the voltmeter itself. Well, it's actually quite simple to service. The only thing you need to do is loosen 2 screws here, and then this board just slides out, including the knobs for the range switches, and you can simply fold this down if you're careful. And let me just, yeah, right there, like this. And now I've got access to this board as well, and that's the board where I need to be, because this one, it only contains resistors. This is the attenuator part, according to me. Wait, let me turn the camera a bit here. Yeah, so this is the attenuator part. These are the switches that you use to select the range of the meter. And these are all resistors with all kinds of weird values to, yeah, get the correct range. So you have here resistors of like 21.6 ohms and 2.315 meg and 68.4 ohms. So these resistors are all specific to this device. And I believe that I don't think we need to do something here. So these are the potentiometers for calibrating, but you can reach them through the back of the board. So I don't think we need to be here. There is a bit of corrosion here on certain pins, so let me check that and where it comes from. But the main part where we need to be is this board, because there are some capacitors in there. So just gonna check here what we need to replace, and I think that should be it for this device. And then obviously also the battery that has leaked. Okay, so I removed all 3 shields. These came off quite well, actually. According to the schematic, I only had to remove these 2 because those are the only ones that were hiding electrolytics, but I decided to remove all 3 of them just so that it's easier to access, and then I can see if there is still no electrolytic hiding in there somewhere. See, we have some transistors. This is the germanium. I think it's the only germanium transistor in the entire set. That's an AC126. We should have, according to the schematic, the big one here. That is a 1000 microfarad. And then 1, 2, 3, 4, 5, 6 electrolytics. I only count 1, 2, 3. Okay, now, yeah, let me just have a look at this and see what is what and what we need to replace. Okay, so I replaced all 4 electrolytics here on the board. They all measured slightly high, or let's say quite high, 30% high, so it was a good thing to replace them. The only thing that I'm not happy about is that for these 3 I had to go up quite significantly in voltage, because I didn't have capacitors with such a low rated voltage. For example, this is a 250 at 3 volts, and I had to replace it with a 220 at 35 volts, so that's 10 times the original voltage, which is not ideal, because yeah, it will be running way below its maximum rating, which is not, yeah, it's not great to form the capacitor and all these things, but I didn't have any caps that were at a lower voltage. Same for this one. This was a 25 at, let me see, 6 volts, and I had to replace it with a 22 at 50 volts, so also 10 times the voltage. Not great. Now the remaining 5 electrolytics that I found on the schematic, those are actually these tantalums over here. So you have 1, 2, 3, 4, 5 tantalums. They are all 15 microfarad. See, they're marked brown-green, 1, 5. Now, I don't really know what to do with these, because, yeah, tantalums, do they go bad? Do they need to be replaced? By what do I need to replace them? They are on the schematic here marked as 15 microfarad, 10 volt, but they are also marked, no, they are actually marked as tantalums on the schematic. Now I see it. Yeah. See, tantal electrolytic. So maybe I need to pick up some tantalum electrolytics for this, because I think they are also a bit, yeah, some of them are tired. See, they should be 15 microfarad. This one measures, I lifted one leg up, 19 microfarad, ESR of 3.7. That seems high to me for a tantalum. Here is another one of which I lifted one leg. Let's see. See, 20 instead of 15, ESR 2.4. So I would think they need to be replaced. The only issue is I don't have any 15 microfarad tantalums in there in my stock. So yeah, I don't know what to do with this. I think I will need to put them back just for a while, and then maybe swap them at a later time. When I order some parts, I will order some 15 microfarad tantalums, and I will swap these out, I think. But for now, I'm simply gonna solder them back in, I guess. the whole point of a tantalum is to have a low ESR, right? So ESR of 3.5, that seems excessive. Okay, let's try to get this old battery out. Oh, that's pretty bad. Yuck. I'm gonna try and not touch it too much with my fingers. Whoa. That's really pretty bad. Now, how to take this out? Yuck. Ugh. Now, the problem is that this battery holder is riveted in place, so I can't really take it off. So I'm just going to try to neutralize the vinegar, with vinegar, the battery acid here. And as you see, yeah. Just gonna let it soak for a while and then rinse it out with some demineralized water and clean it again with some isopropyl and get all the rust and the oxidation off. And yeah, let's hope that does the trick. Okay, so I have put everything back together 2 times, because after the first time the meter didn't work and I thought that I had done something horribly wrong and blew something up. But then I found out that there was I took everything back apart again, and after a lot of bumping and fiddling and twitching, I found out that there was a cracked solder joint on one of the transistors. So I reflowed that one, and now everything is back in working order. Let me show you. See, so we have the meter back again. I still have this board out because, yeah, it needs to be out to do the first calibration. I will show you that later. But see, the meter works. And I had a quick look and it's actually already quite accurate. But let's do the calibration anyway. So the first thing you need to calibrate, and I will show you the schematic of the meter, you'll understand why, is the dot 3 volts, so the 300 millivolt. All the calibrations are on this board, except the 300 millivolt that's on this board. So you need to take this board out to be able to reach that potentiometer. It is, where is it? Over there. And you can't reach the potentiometer on this side because it's in one of these cans, right? So let me get you the schematic. Now, how does this meter work? It looks quite big, but it's actually not that complicated. It is basically an amplifier and an attenuator. So the 2 boards, this is the amplifier board and this is the attenuator. So here on top, that's the amplifier board and that's the actual meter. So what you have here is a simple, there are quite a bit of transistors that are chained, but it's a 300 millivolt voltmeter over here. So this section always is actually measuring 300 millivolt. So here we have the calibration for the 300 millivolt. So when you are using the scale on 300 millivolt, then you just you put the signal straight into the amplifier and you measure exactly what is on the input bus. So that means that the 300 millivolt is calibrated over here. If you measure at a higher range, then you put any of the attenuator circuits with all the very specific 1% resistors that we talked about earlier here on this board. You put any of these resistors in series before you put the signal into the amplifier. So for the amplifier, the input remains the same. You're just attenuating the signal here. So all the other calibrations, see here is the 10 volt, that is the 1 volt, that is the center. So these calibrations, they are done on this board. So arguably, the 300 millivolt is the most important one. So let's start with that one. I have the meter here. I also put a new battery here in the holder for the resistance measurement. Let me just put these things aside here that we can have a good look at the scale. And I'm just going to put it on 300 millivolt. Right. Let's put in the probes from my power supply. And let's put this to, yeah, it's actually quite good set to 0, but let's set it exactly to 0. And then let's enable the power supply for 300 millivolt. And as you see, it is actually not bad. It's really, really close to 30 here. Yeah, you are not exactly, yeah, you can have an idea, but due to the parallax, it looks a bit worse on the camera than it actually is. But yeah, it's quite good. Why is it wobbling about now? Is there maybe interference here? Yeah, probably. Now it's exactly 30 millivolt. Okay. That's interesting. Anyhow, if you need to calibrate it, then here you need to adjust this potentiometer. Yep, there it is. And see, if I now twist this potentiometer, you see, then you can clearly see that we are changing here the reading. So let's put this to exactly 30, so 300 millivolt. Okay, that's spot on. All right, so for the next one, I need to put this board back, so I'm gonna do that, and then I will get back to you. Okay, so I figured out that you can adjust this potentiometer, so that's R113, 113, to adjust the 300 milliamp with this second attenuator board in place, because there is a hole foreseen here in this board so that you can reach the potentiometer on the other side. I already put it in there, and I also use the lazy Susan because it's easier to show you which hole I'm adjusting and then show you the dial here. So let's do this and let's see. Because the board which is in place does cause a bit of interference, I think, with the other board, or the circuit changes a bit and it does affect the alignment. So let's just do it again here. And as you see, we can put it exactly to 300. Yeah. Not quite. That's exactly spot on. Perfect. Now, the next one, what do we have here? We have 225, that's the 1 volt calibrator. 226, that's the calibration for the center position of the indicator. 108, I don't know where 108 is. Here, 108, that's the 3 volt. So I have the 1 volt, the 3 volt, the center, then I still need the 10 volt. Where is that one? I can't find it. Or it's not there. That's also possible. Yep, I can't find it. But let's start with the 1 volt. So let's put the scale to 1. As you see, it is a bit off because it's not showing 300 millivolt, it's showing 290. But let's up the game here and let's go to 1 volt. So that's 1 volt. And it's just only slightly off. So the meter is still quite accurate. And then we should adjust 2 to 5. So that is this guy over here. Yeah. Just put my... Yeah, and see, it is wobbling around a bit, but see, as you see, if I twist the potentiometer, then we are changing the attenuator, and indeed we can calibrate the 1 volt. Okay, that's done. Now let's do the 3 volt. And this one is a bit high, see? So let's go to 3 volt. And here it's a bit low now. Okay. Anyway, the 3 volt is R108. So that is this one. And it's also on the second board. There is nothing here to calibrate. Or it's on the second board as well. So you also have to reach through. And this should be 3 volt exactly. That's 2. That's 1. And it's exactly, well, it's a bit low. Yeah, it's still a bit low. Let's adjust it a bit better. Okay, that's better. What if I put 2 volt? That's nice. 1 volt. That's perfect. Okay, so we have done these ones. Now the problem is there is also a 10 volt calibrator here on the schematic, but I cannot see it anywhere on the device itself. Let me try if I can find it, or let me see if I can find it, but I don't think it's there. Okay, I think I found it. It is located over there, see? So I believe that's the 10 volt calibration. Let's go to the 10 volt. Yeah, I think it is more or less fine, but let's put it on 10 volt. And yeah, we are basically spot on, but if we change this guy, hey, my screwdriver doesn't fit. Hey, this one also doesn't fit. What's this? Tiny one? Yeah. Yeah, it's spot on 10, but okay, let's see. Yeah, indeed. It's the 10 volt calibration. Okay. Now there is one calibrator left, and that's the one for the center position, and I don't know how this works. We can center it with this dial. Okay. Let's put 1 volt to make it life easier. But that's correct, because now I have the scale on 10, and I'm going 1 volt in that direction. If I switch the leads on my power supply, it goes 1 volt in that direction. So this is fine. I think it's okay. If you want to calibrate the center position, and it's R226, and that is that potentiometer over there. I'm not gonna fiddle with that because it seems more or less fine, and the center position is anyway, you don't typically use it to measure exact voltages. You typically use it to put something to 0, to put a voltage to 0, and then yeah, you can calibrate it yourself here by connecting the leads together, setting it to 0, And then like if you're adjusting an IF detector, for example, then you only care about how far it is out from zero. So I'm not gonna fiddle with that. Yeah, I think that's about it. The only thing, I think it's fully working. The only thing that's now left for me is to clean the case, put everything back in the case, and then I can fit it on my shelf. Oh, wait, there's one more thing that we still need to check, and that's the resistance. Because now with the new battery in place, the resistance measurement should work. So let me connect the leads here. So the idea is that you connect your leads together to 0 the meter. So you set it to 0. And let's take a resistor. Just took one that is laying around here. This is a 39K, so let's do times 10. So we should measure 3.9. Yeah, ha, spot on. Nice. Times 1 should measure about 40. Yeah, it's working. Great. Okay, now I just have a bit of cleaning work left to do. And here it is on the workbench, on the shelf, on my new shelf, on the place which I reserved for it. So you're gonna see it more in the next videos because I will probably use it quite often. The main intent is to use it for radio alignment, FM detector alignment and these kind of things. The only thing which I still need is a probe, an AC probe to be able to measure AC and not only DC. That I still need to figure out and build. So I will probably also make a video on that one, but that will be for later. So I hope you enjoyed this video. It was again a video on test equipment, but okay. I love these kinds of devices, and I hope some of you share the same love for these types of equipment. So I'd like to thank you for watching, and I hope I'll see you in the next video. Take care. Bye bye.